哦，是哦，还有那3个 robot。
Okay, so now how about 3 by 3 matrix?
没有，我的很容易吧？
完蛋我的，
到来加一就是这样子。
我可能只放一个，要
So
把它
for
move 来 queen，要把
3
它
by 3
fire 来
matrix,
queen。
how to find the inverse of A?
放 move 跟 fire 2个 function 有点多。
有一点。
So first,
fire 啊
we need to put
应该 fire
A inside
一
this
整条路
matrix.
super
Okay,
比较
好。
像 queen 啊。
then side by side with I. I basically is identity matrix. Okay, and then turn A into an identity matrix. And then this right hand side will be the
foundation 给
turn it into identity matrix I.
这
And
只
then
被
this
打
side will be the inverse of A, right hand side. Okay, so turn A into I. So what is identity matrix? Do you still remember? All diagonal elements are 1, right? Okay, and the rest will be 0. This is an identity matrix. Okay, so this identity matrix, do you still remember reduced row echelon form and row echelon form? So this is reduced row echelon form or row echelon form. Reduced row echelon form above and below all are 0, right? So basically this is RREF, reduced row echelon form. So remember how to get reduced row echelon form? Last week we have learned it. Gaussian elimination or Gauss Jordan. Jordan, right? Okay, use Gauss Jordan 30 to reduce row echelon form.
OPTS 的 quiz 是
Above
下个星
and
期啊。
below. Okay, leading entry all are
幸好这
zeros.
星期没有 quiz， 不然我 GG 了。
So use Gaussian elimination to do it. Okay, so use Gaussian elimination. Turn A to I. Not Gaussian elimination, Gauss Jordan. Use Gauss Jordan. Turn A to I. So put in matrix A. And put the identity matrix okay, on the right hand side. 0.
微妙，
天耶！
还有一点点肉，
Okay.
你还可以再
So still remember pivot cannot equal to 0, right? Pivot cannot equal to 0. So what should we do it over here? What should we do? We need to do the interchanging, right? Interchanging. Okay, do the interchanging. So R1 interchange with R2. So here. Okay, R1 interchange with R2. And R3 remain unchanged. Okay. So now what's the pivot value? Equal to 1. Yes. So here already 0, right? So we don't have to do it. So we need to turn 4 to 0. How to turn 4 to 0? Again, use this formula. Negative elimination element over pivot multiplied by the pivot row plus the elimination row. Okay, so use this formula. So elimination element here will be, put the negative first, will be 4. Okay, pivot is 1, so over 1. 4 over 1 still equal back to 4. So time pivot row is R1 plus elimination row R3. Produce a new R3, right? Okay, So as a result, 4 will turn to 0. So the rest of the row remain unchanged. Row number 1 and number 2 remain unchanged. Just copy down. So this will be 0. And here we need to do the calculations. So negative 4 times R1. Negative 4 times 0 plus 3 will be negative 3, right? And then negative 4 times R1 equal to 3 plus 8 equal to negative 4, right? And then negative 4 times R1 0 plus 0, 0. Negative 4 times R1, okay, times 1, negative 4 plus 0, still negative 4. Negative 4 times R1, 0, negative 4 times 0, 0 plus 1, 1. Okay? Okay. So move on to second column. We do it column by column. Remember, column by column. So second column, what is the pivot here? Pivot equal to 1. Yes. Okay? Pivot equal to 1. And then we want to eliminate negative 3. So again, use this formula. Okay, negative elimination element, negative 3 over pivot equal to 1. So still, again, negative 3 times R, pivot row will be R2. Elimination row R3. Produce a new R3. Negative, negative, positive. Okay? So as a result, negative 3 will turn to 0. Okay? So here we need to do the calculations. So 3 times R2, 3 times 2 minus 4 equal to 2. Right? Okay, 3 times 2, 3 times 1 plus 0, 3. 3 times 0 plus negative 4, still negative 4. 3 times 0 plus 1, still 1. Right. Okay. After that, we move on to third column. So for third column, what is the pivot here? Pivot equal to 2, right? Then we want to eliminate 3 and 2. 3 and 2. So first we try to eliminate 3. So negative elimination element equal to 3. Pivot equal to 2. Pivot row will be R3 plus elimination row R1. Produce a new R1. Okay. So as a result, this 3 will turn to 0. Okay. And here we need to do the calculation. Negative 3 over 2 times R3 plus R1 0. So it'll be negative 9 over 2. Okay. And here we also need to do the calculations. Negative 3 times R3, negative 4 plus 1. Okay. So negative, negative, positive cancel off to 7. Okay. And last one, negative 3 over 2 times 1 plus 0. Still negative 3 over 2. Okay. And then now we need to turn 2 to 0. So how to turn 2 to 0? So negative elimination element equal to 2, pivot also 2. Multiply with the pivot row plus the elimination row. So negative will be 2 cancel out with 2. Will be negative R3. Okay. So as a result, 2 here will turn to 0. And then here we need to do calculation. Negative R3 plus R2. So be negative 2. Negative R3, negative, positive. Negative 1 plus 0, negative 1. Okay. So do you think this is an identity matrix? Yes or no? No, right, not yet. This 2 need to turn into 1. Identity matrix, all diagonal elements must be 1. So how to turn 2 to 1? Okay, take right here. R3 divided by 2, produce a new R3. R3 divided by 2. Okay, so as a result, here will be 1. Here will be 3 divided by 2, negative 4 divided by 2, 1 divided by 2. So negative 4 divided by 2 will be negative 2, right? Negative 4 divided by 2, negative 2. Okay, so in this case, this will be identity, and the right hand side will be the inverse of A. So write it down, inverse of A. So basically you go to this right hand side. Negative 9 over 2, 7, negative 3 over 2. Negative 2, 4, negative 1, 3 over 2, negative 2, 1 over 2. So would you like to try one? No. Hopefully it won't come out in the exam. Right. Okay, so this is a metric inversion for 3 by 3 matrix. So up to 3 by 3 matrix average. Okay. Okay. So now last one, LU factorizations. Okay. So after we cover this, we can cross check LU factorization. Okay, these are quite popular questions. Normally will come up in your test or final exam. Okay, LU factorization. So what does it mean, LU factorization, right? So it means from matrix A, we can decompose it into two matrices, L and U. So matrix A basically is coefficient matrix, all the A element consists of all the A element. Why is L, right? Okay, this matrix L, diagonal element always 1. And here will be L2 1, L3 1, L3 2. Above diagonal always will be 0. Okay, so this is matrix L. And U, what is U, right? U11, U12, U13, U22, U23, U33. Okay, so below all will be zeros. So this is matrix U. So what is L stand for, right? L stand for lower triangular. Okay. Okay, the triangle is on the lower side, right? Can you see that? This is a triangle. U stand for upper triangular. So the triangle is on the upper side. Okay. So this matrix L lower triangular. So lower triangular is always is a square matrix. So what does it mean square matrix? Square matrix mean, for example, 3 by 3 matrix, 4 by 4. If 3 by 4 then is non-square. Okay, 3 by 4 is non-square. So in order to be a square matrix, okay, this L always is the row times row. Okay. For example, here there are 3 rows, right? So it will be 3 times 3, row number times row number. Okay, row number times row. The size is row number times row number. Size. Okay, so in this case it's 3 times 3. Then this upper triangular, right? Upper triangular actually is the same size with matrix A. Okay, same size with matrix A. So if matrix A is 3 by 3, 3 by 4, then upper triangular also 3 by 4. Okay, same size with the matrix A. Matrix L must be square matrix. Okay, so how to get this matrix L and U, right? Look at this matrix U first. Okay, so this is the leading entry, right? This is the leading entry, this is the leading entry. So below leading entry, what do we call it? RREF or REF? Yes, REF. Okay, row echelon form. How to get row echelon form? Use Gaussian elimination. Okay, so just now metric inversion use Gauss-Jordan, right? So this Gaussian elimination can apply to here. Okay, so first we try to apply the Gaussian elimination to get this REF. So take one example. Let's take one example. Okay, so let's take one example. So this is a system of linear equations. Let's see how to solve it by using LU factorization. This should be on this side. Here, negative 5.
Yeah, ito.
Okay, so first try to get the matrix A. So matrix A basically is, okay, it's a coefficient matrix. So write down all the coefficient: 3, -7, -2, 2. Then second one will be -3, 5, 1, there is no S4, so it means equal to 0. So 6, negative 4, 0, negative 5. Negative 9, 5, negative 5, 12. Okay? So once done, check one more time before you start. Okay? Otherwise, if you write down one number wrongly, later on your client will notice your step all are correct, but because of that number, okay, everything's wrong, right? So check one more time. Okay, so in order to get u, right? So we use Gaussian elimination. So now we apply the Gaussian elimination to get the u. Okay. So what is the pivot here? Pivot equal to 3. So 1 to eliminate negative 3, 6, and negative 9. Okay. So first, use the same formula. Negative elimination element over pivot multiply with the pivot R1 plus R2, produce a new R2. So negative 3 over 3, so here will be R1 plus R2. Right. Okay, so as a result, here negative 3 will turn to 0. So R1 plus R2, negative 7 plus 5, negative 2. Negative 2 plus 1 equal to negative 1. 2 plus 0 equal to 2. Okay. And then move on to now turn 6 to 0. Negative 6 over 3 multiply with the pivot row still R1 plus the elimination row R3, produce a new R3. Okay, so here will be negative 3 divided by negative 6 divided by 3 will be negative 2. R3. So as a result, okay, 6 will turn to 0. So 14 minus 4, 10. Negative 2 times negative 2 plus 0, negative 4. Negative 2, negative 5, negative 9. Okay. And then last one, turn negative 9 to 0. How to turn it? Negative elimination element negative 9 over pivot 3. Okay, multiply with the pivot row still R1 plus elimination row R4. Right, produce a new R4. So as a result, negative. Again, 9 divided by 3, 3 times R1 plus R4. So as a result, here turn to 0. Okay, so the rest just write it down. Everything. Okay. So now, what is a pivot? What is a pivot? What is the value of pivot? Second column, negative 2, yes. Negative 2. So turn 10 and negative 16 to 0. Okay. So negative 10 over pivot negative 2. Multiply with the pivot row R2 plus R3. Produce a new R3. Okay, so we find R2 plus R3. Produce a new R3. Okay, so as a result, 10 will turn to 0. Okay, so 5 times R2, R3. maybe 1. Right. Yes. 5 times R2. Yes. Negative 4. This will be 5 times R2. R2 equal to negative 1, right? Here equal to 4. Yes, yes. Here equal to negative 9. Okay? And then turn negative 16 to 0. So negative 16 over pivot negative 2. Pivot is negative 2, right? As the pivot row, multiply pivot row as elevation of R4. So will be negative 8. Okay? Okay? Correct? Just now this one is correct, right? So this one is correct, what I did. Right? Oh, this one is 4, not negative 4. Yeah. It's 4. I confused this one with this one. 4, yeah. Okay? So as a result, this will be negative 1. This will be 1. Negative 8. Yeah. Okay, so as a result, negative 16 will be 0. Negative 3. Okay, 8 times. That's 3. Okay. Okay, move on to third column. So third column, what is the pivot value now? Yes, negative 1. Okay, so turn negative 3 to 0. Okay, so negative elimination element over pivot times pivot row R3 plus elimination row R4 produce a new R4. Okay, so as a result, negative 3 will turn to 0. Right. Okay, here as the off will be negative 3. Okay, so negative 3 plus 2 negative 1. Okay, so now under the leading entry, all elements are 0. So this is U. Okay, so write down U. U equal to this. Okay, so use Gaussian elimination to get it. U. Use Gaussian elimination. Okay. So after that, we try to get the L. So all the diagonal element will be 1. Okay, so matrix A is 4 by 4, right? 4 by 4. So which means L also 4 by 4. Diagonal elements always are 1. Okay, so it will be L21, L31, L32, 41, L42, L43. Oh, and then let me correct the alignment. Okay. So again, we also do it column by column. Column by column. Start with the first column. But this one is much more easy. Okay, much more easier. Okay, this is first column, right? First column. So anyone pay attention here? Listen here. Okay, let's see the magic. Okay, go to the matrix number 1. Matrix number 1. This one, right? This one. Where is the column number 1? This is column number 1, right? Okay, no? So column number 1 map with column number 1. Okay? Column number 1 map with column number 1. So write it down. So what are the values for the column number? We will check the color. Okay, what are the values, right? 3, -3, 6, -9. Okay? 3, -3, 6, -9. 3, -3, 6, -9. Okay. If you look at this element must be 1, right? How to turn 3 to 1? Divide by 3. Okay? So divide by 3. So as a result, here will be 1. So 1 equal to 1. So which means the rest of the element must be divided by 1, by 3. So -3 divided by 3. 6 divided by 3. -9 also divided by 3. So equal to -1, 2, -3. Okay? Okay. So the first column it will be 1, -1, 2, -3. Stick together. Okay? And then move on to second column. Okay? 0 we ignore it. 0 we ignore it. We start from 1. 1, L32, L42. Okay, no? Okay? Then move on to second column. Start from 1. Okay? So 1, L32, L42 is at start from row number 2, right? At the second column, row number 2, second column. So now we come to the. So this is first matrix, right? We come to the second matrix. So this is second matrix, right? So we map with the same position. Start from second row, second column. Okay, -2, 10, -16. Okay, second matrix with the same positions. So -2, 10, -16. Write down. -2, 10, -16. So how to first element equal to 1, right? How to turn -2 into 1? Divide by -2. Okay. So every element divide by -2. Okay, so as a result, it will be -5, 8. Okay, so fill up over here. Okay. So now come to the third column, the last one. Want to find L43, L43, L43. Okay, L4. Start from 1, L43. Okay, so go to the matrix number 3. So this is matrix number 1, right? Number 3, number 1, number 2, number 3. So at the same position, map with the same position. So column number 3, start from row number 3. Okay, negative 1, negative 3, map with this. Okay, so one by one. So write down negative 1, negative 3. Yeah, negative 1, negative 3. So how to turn negative 1 into 1? Divide by negative 1. 1, 3. Okay or not? Okay. So the question always come up, ask you to find L and U. Okay, find these two. Okay, so complete this. So 1, 3. So this is L. Okay. So complete the matrix L. Fill out all the values and we continue. So basically this is step number 1 only. Okay. Step number 1. Okay. Okay, now let's move on to step number 2. Okay, we know that A, okay, A we split into two matrices, right? L and U. Okay, L and U. So step number 2. We know that A split into two matrices L and U. So this matrix, again, matrix system is A times X equal to B, right? Just now during the matrix inversion, we have covered this, right? A times X equal to B. So this A, we turn it into L and U, right? Okay, A, we turn it into L and U. So in this case, there are how many matrices here? How many? 1, 2, 3, right? Okay. Very difficult to solve 3 matrices together. So we need to turn it to 2 matrices first, then only solve it. Okay, how to turn it to 2, right? So which means we need to simplify it. So let the y equal to u times s. So as a result, this will be y. So be L times y equal to b. So then easier to solve it. Okay. So y is L, right? Just now we have found out. Again, this matrix L, we found out over here. So write down all the value from here. Get from here. Write down. So it's 1, 0, 0, 0. Negative 1, 0. 2, negative 5, 1, 0. Negative 3, 8, 3, 1. Okay, correct or not? Check it. Okay, y will be y1, y2, y3, y4. So what will be the values for b, right? So remember, b is on the right hand side. B is on the right hand side. Okay. So So B is over here. Negative 9, 5, 7, 11 from the equation before. Okay, from the equation. From the equation. So be negative 9, 5, 7, 11. Okay. So how to solve it, right? How to solve it? Still remember back substitution. Okay. But this one is a forward substitution. Back substitution, we start from the last row, right? Okay, this forward substitution, we start from the first row. So 1 times y1, 0 times y2, be 0, 0 times y3, 0, 0 times y4, 0. So it means 1 times y1 equal to right hand side negative 9. Okay, now? Okay, so this is a value for y1. And then move on to second row, negative 1 times y1, 1 plus 1 times y2. The rest times 0 with 0, then equal to right hand side equal to 5. Okay, so y2 equal to 5 minus 9 equal to negative 4. So highlight all the answers. Okay, then move on to the third row. 2 times y1, negative 5 times y2, plus 1 times y3 equal to 7. Okay, so 2 times 9, negative 9, minus 5 times y2, y2 equal to negative 4, equal to 7. To 7. So minus plus together equal to 2. So y3 equal to 5. Okay, and then last one. Negative 3 times y1. Last one. Okay. Negative 3 times y1. 8 times y2. 3 times y3. 1 times y4 equal to 11. Okay, plugging all the value. y1 equal to negative 9. Y2 equal to negative 4. Y3 equal to 5. Okay. Negative plus 15. Okay. So minus out equal to 10. Right? Y4 equal to 1. Okay, then come to the last step. What's the last step, right? Last step. So still remember just now. Still remember? We let the y equal to u times x, right? Y equal to u times x. So which means u times x equal to y, right? U times x. So what is this U, right? So U just now we have found out. So U is this matrix. Okay, U is this matrix. So plug in this matrix. So right now, okay. So X are the solution we want to find out. X will be the solution we want to find out. Okay, Y. So Y will be Y1, Y2, Y3, Y4. Okay, so plug in the value for Y. Okay, so Y1 equal to -9, Y2 equal to -4, Y3 equal to 5, Y4 equal to 1. Okay, so how to do it? So how to find the solution for all the X, right? Use the back substitution. Okay, so start from the last row. -1 times, okay, S4 equal to what? So it means S4 equal to -1. Right. And then move on to second row. -1 times S3, 1 times S4 equal to 5. So S3 equal to -6. Okay. Okay, and the last two, I want you to do it as a quiz. Find S1 and S2. Quiz number 2 today, simple one. Quiz 2. Find S1 and S2.